Welcome to the Math Ed Podcast. My name is Sam Otten from the University of Missouri, and my guest today is Amy Hackenberg, who's in the School of Education at Indiana University. Amy, thanks so much for being here.
Oh, thanks for having me, Sam.
And I am looking forward to this conversation because you had a recent article that came out in the Journal of Mathematical Behavior, and that new article is called Decentering to Support Responsive Teaching for Middle School Students. So I was kind of interested in the article, and Amy, we started to kind of reach out about it. But it turns out, it's kind of cool, this is pretty much a direct sequel to an earlier article in JMB. And that
Mhm.
article is from 2023 by the same folks.
Yeah.
And that article is called Middle School Students at Three Stages of Units Coordination Learn to Make Same Speeds. And so this is kind of a fun opportunity because we're going to actually try to talk about both of these articles because they really do go together as an interesting kind of connection. I'm used to seeing articles that come out from the same project or something, but these are really interesting because it's the same author team and the same journal, and you really pick up on some of the ideas and take them to the next step. So is it okay to try to talk about both of those?
Of course. Yes, absolutely. And I just want to call out my co-authors, Fethiye Aydeniz Temizer from Turkey, and Rebecca Borowski, who's at Western Washington University right now. And they are both fantastic co-authors and former students of mine who are now assistant professors in their own regions.
That's great. So let's go ahead and start with the 2023 article. So this is the one about
Mhm.
middle school students at the three stages of units coordination. So I wonder if you
Yeah.
could maybe tell us the motivation and the purpose of that 2023 article.
Yeah, so it comes from a project where I was really wanting to teach students at all three levels of units coordination or stages of units coordination in the same middle school classroom. We have found out through other studies, including Zwanch Wilkins study and educational studies in mathematics from 2021, that there are students at all the three stages of units coordination in middle school classrooms. That's also been borne out in my own research. And I see this as an aspect of classroom diversity that really affects how students participate and what happens with them in the classroom, but that doesn't get much attention because we usually think of diversity in other ways, other very important ways. But this aspect of diversity of thinking doesn't get as much attention. And so I had a big funded project to try to study how to differentiate instruction for middle school students operating at these three stages of units coordination. So the whole project was actually geared towards that. And so this was one example of that came out of a classroom study at a later phase of the project. And I guess I just want to point out that we anticipated that the thinking of students who are at some stages of units coordination, there's three basically, at stages 1 and 2, might appear only as deficits in the classroom, being seen as not being able to do things. And we were trying to bring out what they could do and try to support their progress on it rather than having them sort of appear in deficit ways in terms of how they think. So I guess what I'm saying here is the motivation for the 2023 article, to be really honest, is they really came together. The original submission back in probably 2022-ish was a paper that was trying to combine both a paper about student reasoning and a paper about the teaching that supported that reasoning. The content of both papers I was trying to put into one paper. Well, it didn't work at all because I had to be so we had to be so limited in what we said to try to
Yeah,
accomplish both of those things, even though
neither
I
one
felt
could
like
kind of get the full treatment that they needed.
yeah. And I felt like together it was a really interesting contribution to have evidence of learning across the stages of units coordination and the teaching that supported it. But I just couldn't make that, and we couldn't do it in one paper. So we split it apart into two papers, and so in a way, the motivation for both papers is kind of the same. But then part of the project was definitely to try to study students' thinking in the domains of rational number knowledge and algebraic reasoning, middle school students. And so we were wanting to find out about how students at these different stages of units coordination, and I can say more about that, conceive of proportional reasoning as a really important middle school topic, and not much research has actually addressed that to this point. So that was a reason to really do the focus on student reasoning in terms of making same speeds.
It is interesting to kind of look into this sort of work because I've taught the graduate class that we have here at Mizzou about
Mm-hmm.
mathematical thinking and learning, and we've
Mm-hmm.
actually read some of your past work in that class. But a lot of the research on mathematical thinking with students, they do look at individual students and how that thinking moves forward, but you're taking on the real complexity of in a classroom, you have all
Mm-hmm.
of those ways of thinking in the same room, and a teacher is trying to
Right.
somehow make it work. So to me, that's kind of like It's taking the detail and the insight of mathematical thinking research, but it's also taking the reality and the complexity of a classroom with people milling around and like all of those personalities going on at the same time.
Yeah, yeah. So we were really trying hard to do that. And what's interesting is that we actually found we did this in an eighth grade classroom too. That is, I haven't written as much about, but hopefully soon finish writing about that. But we found percentages that was somewhat similar to Swanch and Wilkins's percentages. I won't, say everything about that, but basically in these regular seventh and eighth grade math classrooms, we found about 25% of the students were operating at stage one, about 50% or a little bit more, maybe up to 60% were operating at stage two, and the remainder at stage three. That's a little actually better than what Swanch and Wilkins found in their study of fifth through ninth grade students. But the point is, and saying that detail is that is this very real that students, even in a college town, which is where I am, which has a lot of educated people in it, not all the students in the middle school are operating at high stages of units coordination. You have a big variety, and that's actually a huge challenge if you really want to take seriously trying to understand students thinking and meet them where they are and support them to make progress. But yes, the complexity of the classroom we were trying to definitely tackle.
Yeah. And before we get into some of that complexity and from the study and how you handled that, just give us a quick rundown of those three levels of the units coordination. Just if you give us the summary version,
Yeah,
then we can kind of go on from there.
I'm gonna try. I'm
I'm
not
going to
very good
ask
at
you to
this.
condense years of research into about a minute or two.
I might be able to do it. We'll see. Okay, you can call me on it when I'm gone too long. So broadly speaking, units coordination is a structured way for researchers to think about the multiplicative reasoning students are engaging in. And it really has to do with how people are thinking about units and units of units. So a unit is like a one. It's also an inch, or it's also the length of a paperclip that I'm using to measure something, and how people organize those units. Research has found that there's pretty significant differences in how people conceive of units like ones and groups of ones and measurement units and how they use them in their reasoning. So really that's like kind of the heart of units coordination. And it has just a lot of implications because we use that to do so much mathematical activity. So it can affect things, it can affect reasoning with fractions and algebraic ideas and quantities and all kinds of multiplicative relationships that you might be working on. And of course, in middle school, that's rampant. I mean, just about every middle school topic is multiplicative in nature from our perspective. So research has basically found that students up through, say, high school are operating with at one of three different stages. The use of the word stage is somewhat controversial. I'm sure
Hmm.
it's
Hmm.
probably not necessarily well. Anyway, there are reasons to use it, but
Yeah.
anyway, so I use stage to mean that there are ways of thinking that are kind of grouped together for students and that don't change quickly or easily. Like it takes a significant reorganization of ideas to move from this way of thinking to this next way of thinking. So the word stage is used because it seems to describe that well, and that there are some different, sort of qualitative differences between people operating in one way, people operating in another. If you can see stage in that way, then maybe it won't be objectionable to use. I'm not sure.
Hmm.
But anyway, students operating at stage one are basically in a ones world. The way they think about number is not multiplicative. So when they think about a big number like 78, they need all 78 ones to think about that number. So they
Hmm.
don't think like we could, like, oh, I just need one, and I can imagine repeating it 78 times, iterating is the word we usually use for that. Like you and I can think that way, that we actually don't have to have 78 ones. We just have to have one. But students at stage one don't think that way. And so that has a lot of implications, even though they can think of 78 as
Hmm.
like one big unit, so they can take it as a unit. They have a really interesting different way of thinking about how ones and 78 are related that we, wouldn't think of. We wouldn't,
You can kind
yeah.
of put 78 things in a bag, but there's actually 78, literally 78 items in that bag.
Yeah, yeah, yeah. So it makes working when they're young, it makes working with big numbers hard because you have to, if I'm going to think about 100 even or whatever it is, I have to have like 100 items to really think about that. That'll make more sense when I talk about students operating at stage two, although I kind of alluded to it a little bit because students operating at stage two do think about 78 as just, oh, I don't need 78 ones. I just need one. I can imagine, I can anticipate taking that 78 times or just repeating that 78 times.
Mhm.
So they anticipate both the iteration, the repeating, and they anticipate the result. And so that makes their number sequence multiplicative for the first time in the way, that we typically describe it. And there's a lot of power to that, I won't go into all the different implications of it, but it has even implications for fractions. Like if you think about a unit fraction, for the first time, students operating at stage two can say, oh yeah, 1/5, I would have to take that 5 times to make a whole unit. 1/5 of a unit would need to be repeated because they kind of use their idea about that multiplicative relationship with whole numbers in the context of fractions, or they can do that. It's not automatic, but they can learn to do that. And then one important thing about stage two as well is that students can build multiplicative relationships that to us feel like they're multiple different units. Like if they were doing 5/7s, they'd be able to figure that out as 35. And they'd be able to tell you afterwards, like if you said to them, what's 5 times 7? And they just did a problem like that, they'd say, oh, well, it's 35. So they
Mhm.
can, quote, learn multiplication facts. But as they continue to work on math problems, that structure is something they don't maintain. So 35 becomes just a unit of 35 ones. It doesn't maintain itself as a structure of 5/7s. And that has obviously, well, probably, hopefully, obviously, a lot of implications for their life as upper elementary and middle school students in terms of even just knowing multiplication facts. I mean, both students at stage one and stage two, it's like it's a really chore to learn those
Mhm.
multiplication facts. It's not automatically contained in their ideas about number, although students at stage two can make much more progress because of the nature of their numbers. I haven't explained everything about that, but
Yeah.
anyway, moving on.
Mhm.
Students
Mhm.
at
Yeah.
stage three, they do anticipate this kind of structure where 35 is, 5/7s. And what we say is that not only do they have like ones are multiplicative in their number sequence with numbers, but they also anticipate a number like 35 could be made from a composite unit, a unit of units like 5 or 7,
Mhm.
iterated some number of times. So they actually not only can, think of 35 as, one taken 35 times, but it could be some other amount, composite unit, a unit of units taken some number of times. The fancy word for that is that they have iterable composite units, not just iterable units of one,
Mhm.
like students operating at stage two.
And even the 35 itself could start to be iterated, right? Like that's where you can
Oh,
start to
yeah.
get like
Yes.
35 become
Right.
70, but then you still see the
Sure.
70 as those fives in there or those sevens in there.
Exactly, exactly. Yeah. So they can build basically what research has found, although people are doing some work on this right now and might change things, but that once you are operating at stage three, you can nest to those structures. So you might not be able to be aware of like 5 levels of units at once, but like you can take your 3 levels of units in different places and kind of switch
Mhm.
between them, and that's fairly, sufficient for solving a lot of the problems that we
Yeah.
solve, at least in middle
Uh,
school and high school. So anyway, but I don't know how to do Sam.
no, that's great. I thought that, yep. Gives me a good
I mean,
sense. I think we're
okay.
good. So let's now go back into the study.
Yeah,
You kind of played multiple roles. Can you kind of just
sure.
broadly, again, I'm asking you to condense a lot of things into short amounts of time, but
No, no, it's
can,
fine. Yeah.
can you let us know the setting for the study and then how the
Yes.
multiple roles were kind of handled? Because there's kind of teaching going on, but there's also research going on and like balancing those.
Yes, yes, yes. Yeah, I was actually, I really only had one role, to be honest. I was a teacher researcher. I wasn't I wasn't a classroom teacher. I wasn't I didn't have control over grades, but I was a teacher researcher working with a classroom teacher, and we were sort of co-teaching a unit together. She had been involved in a year-long study group that I had with middle school teachers from around the state, and we were trying to study how to differentiate instruction together. And out of that year-long study group that happened as part of this big project, some of the classroom teachers said, yeah, you can come and we'll try to differentiate instruction for a single unit. So that's what I was trying to do with her and a research team. I had a great research team, including Fethiye and Rebecca and very many other people. Actually, it was many people research team that made this happen. So this was the third phase of this big project, and we were working with classroom teachers, as I said, who agreed to try to do this work with us for a unit.
And then what data were you actually able to gather? Because I know that's a complex
Okay.
environment. What can you
Yeah,
grab
yeah.
from that for analysis?
So we actually filmed classrooms with four cameras, six microphones that fed into a mixer. At the time, you needed that. I don't know if you still need that now. And so we were trying to get a good overall view of the classroom, but then we also really wanted to get in depth. So there was lots of video data, obviously, based on what I'm saying. And we had two cameras that roamed, two cameras that were stationary. These six microphones feeding into a mixer, all that produced a lot of video data, some of which we wanted to have all together to see a whole view of the classroom, but often we were using, separate feeds to try to do our analyses. And then with the students, we wanted good audio of them. So we had audio recorders on the tables. There were usually 6 to 8 groups working in the classroom at a time. And so we picked up the audio, and then we had focus students in each of our classroom studies that we really followed carefully. So we did initial interviews with a lot of students, actually. Then we picked our focus students, and then we did mid-unit and final interviews with them about the topics in the course, as well as about the differentiation of instruction. So yeah, it was a lot of data.
Sounds good. So let's
Uh,
go ahead and kind of cut to some of the findings. So you have these students that are at different levels or different stages of the unit's coordination, but then during the teaching and during the unit that they're working on,
yeah,
one of the things they have to do is try to take cars and then have them travel the same speed. So
right,
there's kind of this working of rates involved in trying to get the rates to be equal or equivalent in certain ways.
right.
So what did you see in terms of how those units coordination levels, how did that relate to the ways they made the cars go the same speed?
What we found really, and so I'm kind of maybe answering takeaways too from the 2023 article
Hmm.
as I respond to this question. But so students at all three stages were able to make the cars travel the same speeds. And of course, the task was, initially we explored cars not going the same speed in order to like investigate the nature of speed with this app. That Joanne Lobato has used in her projects, in her Math Talk project. And it's actually Janet Bowers who made the app. Thank you, Janet. It's an awesome app. So we gave them a pair of numbers for one of the cars, a distance and a time pair, and they had to figure out a distance and a time pair for the other car to make it travel the same speed, but not the same distance and the same time, obviously. So what we found was students at stage one did succeed in doing that. Our focus student is the example of the student who succeeded the most at that. But they, in the process of doing that, basically had to build the idea that a journey could be a length, that a journey could be represented as a length, and that it would have a distance and a time value. So basically, I think we saw the construction of a composed unit there with Emily in the paper, and did not have that initially. There was repeated me working with her, asking about, she had an idea about doubling early on that kind of came from her group, but how does doubling show the same speed? They had to justify why doubling the distance and the time would produce the same speed. And that was a protracted process, which in that process, we realized that she actually wasn't thinking about a journey as a distance. And in the process of talking with me, made that idea and then was able to iterate it and see that, oh, if it's going 18 miles in 3 minutes and the other one's going 36 miles in 6 minutes, I can just do two of those. Now, that was a huge accomplishment that happened over 9 minutes in the classroom, with me interacting with her. And we didn't in the process get to really talk about why does that produce same speeds. But it was still a great learning for her that I argue in the paper, we argue that she accomplished constructing journeys as connected numbers and was able to iterate them and see that journeys can be made by multiple iterations of the original journey. So it's a step towards being able to say why it's the same speed. If each of the iterations is the same speed, the larger journey has to be the same. But she didn't ever actually get that part out. I think because we were so focused on the construction of just journey as connected number and being able to use that in iteration. And then students at stage two were, super interesting because the ones that we followed as our focus student and her partner made two different schemes for solving the task, a multiplying scheme basically and a dividing scheme. And even though they were related, they were not connected. And in their minds, they were separated. And we explained that based on the structure, their units coordination structure. And also, I think the most maybe interesting part of that was that when they divided, so if they had like 15 miles in 6 minutes and they tried to divide to make same speeds, which by the way, initially they didn't think that would work. But when they did divide to make same speeds, they basically didn't seem to create the result of the divisions didn't seem to be multiplicatively related to larger journeys. So it was like the division produced something and they could verify that it was the same speed, but it didn't connect up in their minds with the larger journeys that they had made. We have
It
some
was maybe
evidence
like
from
drilling down to a smaller component or something and not really expanding out to the bigger journey.
yeah. So the results of division didn't seem multiplicatively related to larger journeys. And that was partly we had evidence of that because Lisa in the paper would make that. But then when you asked her how many of those smaller ones were contained in a larger journey, she didn't know. She had to count. It wasn't like she said, oh, well, two here, so there must be four because it'd be two here. She didn't have that structure that she built. So for me, that was super interesting because it made sense based on some of the things I know about students operating at stage two and other contexts. But also, to me, it's kind of, well, I've been sort of a fan of covariational reasoning for a long time, even though I don't do it in my research. And so I've been thinking about chunky and smooth covariational reasoning because I have other colleagues who do that work. To me, it sort of responded to that because the basic idea with chunky covariational reasoning is that you only reason about what's going on at the end of a chunk. You don't go like inside the chunk of time or inside the chunk of distance to figure out like what's going on sort of in a more continuous way. And to me, when I saw this, I thought, oh, this might be a big factor in why that happens. And that it's not just about, I mean, Lisa and anybody would say like, well, yeah, there are distance and time values in between those chunks, but the reasoning, because of the nature of the going into these little parts, is not multiplicatively related to the larger journeys that they were making. It seemed like there was a potential there for not being able to reason with what's inside that chunk. So that's a connection we tried to make in the paper. I don't know if that's clear or not. Anyway, that to me was like super fascinating. And then our student at stage three was able to not only construct journeys as she could anticipate the iterative relationship between any journey she had and other journeys that she was making, but she also did that with the result of division. So like she had 15 miles in 9 minutes. She divided immediately and said 5 miles in 3 minutes should work. And then she kind of tested it out. And then she said, like, oh, well, anything that could sort of come to 5 miles in 3 minutes, we should reduce down to 5 miles in 3 minutes, I think were her words, would work. And in the process of kind of elaborating that with her, it seemed like basically she could take a fraction of her composed unit and anticipate iterating it and the results of iterating it as producing same speeds. So there was it was cool to see that and it kind of made sense to me again based on how I know stage three students that she would do that, but we didn't know for sure that she would, and it was really neat to see the power of that. I think there's a lot of power in creating a iterable composed unit as well as the fraction of a composed unit as an iterable unit. That's a mouthful, but it's the root of measurement. I think the root of constructing a measurement unit. I've said a lot.
No, but it's good. I mean, so you said like,
Mm.
some of it is kind of expected from them thinking in these
Mhm.
the stages that you talked about before. But to me also, I keep thinking about how it's not just cool to see the students doing that, but to realize that this student reasoning came out from an actual classroom setting where they were learning this
Mhm.
stuff for real. It wasn't
Yeah.
just like a lab, interview kind of
Yeah.
thing.
Yep. We were using CMP3 as the curriculum materials, and we had a classroom teacher who was very, very interested in student thinking and was herself doing her presidential like application for presidential honors that year. So she's very, herself accomplished, and she was very open to everything we were trying to do because she already had her classroom basically organized that way in terms of, investigations of problems. So it was definitely facilitated by that,
hmm
for
And
sure.
the students could find success. Like you said, they were able to actually solve
Hmm.
the task, even
Right.
though they thought about it in these different ways.
Right.
So for this 2023 article on the middle school students, are there any final takeaways from that article, or do you want to help us kind of bridge into how this leads into the 2025 article?
No, I think I've sort of covered it. I mean, as you said, like the sort of the byline might be students at all three stages learn to make same speeds, but what they learned was different, fundamentally quite different. So, I mean, a question sort of is how okay are we with that as a field and as people who are working in school and policy makers? I mean, I feel like there's not that much room often these days for having different expectations for students, but you can see like there's a lot of positives to being able to recognize that, I think. So, yeah.
Yeah, let's go ahead and make that turn towards the 2025 article, which again is called Decentering to Support
Mhm.
Responsive Teaching for Middle School Students. So now we are shifting the focus towards the teacher researcher, but the instruction that's kind of happening and looking
Mhm.
closely at some of the ways that decentering help to provide the opportunities for students to do this kinds of thinking and for these things to happen. Yeah, let's continue to set the stage. What do we need to know about decentering now? Decentering comes on the stage here in the second article as a pretty
Yeah.
important concept. So help us
Yeah.
get familiar with decentering.
So we weren't, I mean, I come from a tradition where decentering was something that I was trained in, basically, but I wasn't thinking of this study in those ways. We sort of say this at the start of that paper. We were trying to differentiate instruction for the students at different stages of units coordination. That was our main goal. We weren't really framing it in terms of, decentering. But as we were analyzing the data and sort of expanding our analysis of the interactions with the students between the research team and the students in their groups, we began to sort of notice that, oh, actually, these concepts of decentering that are being written about more by like Marilyn Carlson and Sanem Bassetter are actually very, very compatible with what we were trying to do. And so their 2022 paper in MTL was super very helpful for us in trying to figure out and get a handle on what we were actually trying to accomplish, even though we didn't have those terms initially to talk about it. So anyway, decentering basically means you're trying to set aside your own perspective as much as possible. It's not possible fully, but and set it to the side and not assume the people that you're interacting with have that perspective. You're trying to understand their perspective as best you can, as faithfully as you can, and then interact based on that. And that can be in a context of emotional decentering, which I think people do probably maybe more easily than cognitive decentering, maybe. I think possibly teachers may emotionally decenter because they know their emotional experience isn't the same as their students. They try to understand their students' emotional experience. And then, teachers who are sensitive are trying to interact with the students based on that, just for an example. Cognitive decentering is harder because, especially I think for secondary teachers, because the idea of students not thinking similarly to me and having a whole way of thinking that could be useful for me to find out and build upon is not necessarily like second nature to them. But that's the idea behind cognitive decentering is I've got to not assume that the people I'm interacting with are thinking similarly to me mathematically. So I set my own ways of thinking to the side as much as I can and really try to see what they're doing, how they're doing it, and then try to build on it, interact with them, ask questions, comment on what they're doing to see can they make progress from where they are. And, you can theoretically you could decenter in other ways too, sociopolitically and etc. But emotional and cognitive are the ways I basically have studied in my career so far. So anyway, the that sort of fundamental stance was something that we were engaging in, even when we didn't really completely identify it that way. And as we began to, analyze the data from the perspective of understanding the teaching that went on to support the learning, it became a really useful sort of stance. And the decentering actions from the Bassetter and Carlson article were very helpful in coding our data and trying to understand the patterns that were going on in it.
Yeah, so
Yeah.
there's definitely, decentering all over this article in the 2025 article in JMB. But I basically want to just ask you to touch on two things. How was the
Mhm.
decentering important for the learning? Like, in what ways
Mhm.
did the teacher or the knowledgeable
Yeah.
others, by them decentering, how did that help the students' learning? And then I'm also going to come back and ask about as a teacher, how did the teacher accomplish decentering, whether that was you or it could be somebody else, but like what are the
Yeah.
actual moves of decentering? But let's start with the students. Like
Okay.
why was that
Sure.
helpful to the students that the teacher got themselves out of the way, out of center stage and kind of tried to put the students' own thinking first?
Yeah. Well, so for example, with Emily, she's the student operating at stage one that I mentioned earlier, who hadn't made the idea of a composed unit really for distance and time, and definitely didn't have the idea of being able to represent a journey, distance and time associated together as a length in order to maybe justify why doubling would produce same speeds. So one, response to Emily when she doesn't know how to draw a picture and and I'm interacting with her and asking her, well, how could you draw a journey? You don't have to draw a car. You don't have to draw like what could represent a journey going from one place to the next for this car. And she doesn't know. One option would be, well, hey, Emily, why don't you draw a segment? Here, let's draw a segment. See if you can do that and this way. And then how could that would be one way to interact with her. I was trying to see, could she produce a segment based on me asking her questions about how could you represent doubling? So I was trying to help her build a little bit on what she was doing in mentioning doubling and consistently saying that doubling was important. You wanted to double the distance and the time, but I was refraining from imposing how I would think about it on her. She did end up producing a segment. I think that segment probably meant something different when she first drew it than what it meant to me. So she drew a segment and she wrote like kind of an arrow. And the fact that she had her 18 miles in 3 minute segment, the same length as a 36-mile 6 minute segment, that they were the same length kind of indicated to me she probably was thinking of them more as a motion than as like showing a distance accomplished in a certain amount of time. So there was a little bit of me then saying, well, I see this way. So there was maybe a little imposition there, my own thinking on make an interpretation of what she drew, but she was able to run with that and see like, oh, I see the 36-mile in 6 minutes would be two of these, like I'd fit it in two times. So it's not that you don't have, your own first order knowledge as a teacher researcher definitely plays a role. You can't get rid of it and it's going to be there, consciously or not. But I think it surfaced her ability to make this construction and create something that was definitely she knew it was a new idea for her. So there was like some pride in that, and I think feeling like, oh, I made something that I don't know exactly how to say why this is the same speed, but I made something that I think shows something about this.
Well, this I kind of noticed this earlier because I had read the 2025 paper, and now I'm definitely noticing it here too. Is just even the way that that feels, like you said
Hmm.
here, that Emily had a new idea for her. Like she was
Hmm.
part of coming up with that new idea, which is
Yeah.
different and I think that comes from the decentering because that means she was working on ideas and then she kind of was able to bring an idea forward
Yeah.
versus like receiving something that somebody else is trying to explain. So if,
Right.
if, if
Right.
somebody's trying to explain it and I'm trying to like I'm a teacher, I'm trying to get the student to grasp my idea, the best that can happen is that they grasp it, but that still feels like they've received something. It doesn't feel
Right.
like
Yeah.
they formed a new thing
Hmm.
themselves.
Yeah, yeah, that's a great point. And I think you can see it with Lisa and Sarah too, because especially when they started to explore smaller same speeds, they pretty easily did the doubling. Well, it wasn't totally easy, but they did the doubling and they represented it, especially Lisa represented it pretty swiftly. But then when they tried to produce smaller same speeds, Lisa had an idea about dividing, but she didn't know how to draw that exactly, and she didn't know what the implications were of that. And they started talking about subtracting things off, and so, Rebecca was actually interacting with them at that time. And rather than just be kind of like, oh, well, it works the same way, just here, just do what you did with the multiplying, but it works the same way. Rebecca just asked like questions about, well, what do you mean subtracting? Are you subtracting, what are you subtracting? And it kind of indicated that they were subtracting like a journey, not just like single units.
Hmm.
But like it really surfaced that there were issues in how they were thinking about division that were not transparent or not similar to how Rebecca and I were thinking about it or the teacher, and that were worth coming out because it was like a worthy investigation for them. And the process of the investigation was that they did realize, like, oh, division does work, and we aren't just subtracting, but still, what they produced as an idea wasn't real, connected all the way up from what we could see with their ideas about multiplying. So that was another instance where their ways of thinking came out in a way that I think was fruitful for them to explore, and that wouldn't have come out if we weren't really trying to practice this decentering with them.
Yeah. And I go back to also how you started by talking about differentiation and really trying to
Mhm.
support students who are at different places in their thinking. I feel like the decentering to me feels like kind of an equitable approach because it allows every student to have the chance to kind of move forward from where they are. Whereas if it was sort of a teacher thinking forward, where it's like the teacher is going to kind of present what they're
Mhm.
thinking about, I feel like that might advantage certain students who are closer to that teacher's thinking as
Oh,
like,
for
yep,
sure.
yep, this is all making sense to me. I'm
Yeah,
right on board with what the teacher's pushing, and that might
for sure.
disadvantage some other students.
Yeah, yeah. I mean, that's Joanna right there, right? Joanna could make lots of interpretations of what her teachers were saying because of her powerful nested multiplicative structures. And yet, still with her, we our decentering with her allowed her to articulate that she was thinking of a fraction of a composed unit as something that was like the root of creating lots and lots and lots of same speeds. So I don't want to leave her out too.
Hmm.
Decentering was good for her
Yeah.
too.
Well, you mentioned a
Um,
couple teaching moves that you did or that Rebecca did or
yeah.
others. So can you encapsulate for us a few of the ways that the teacher could actually accomplish the decentering?
Yeah, yeah. What we kind of found out is, these come from the codes from Bassetter and Carlson, and there were four codes that we used a lot: AQST, FMST, LST, and PS. Okay, what do those mean? So AQST and FMST are both about asking about students' thinking or following up on trying to understand students' thinking. I won't be quoting them verbatim, but basically they were like investigating students' thinking and following up to understand more about students' thinking. LST was leveraging students' thinking, which for us came out, we named that a thing. We named that a leveraging question, which was to be able to think about what students are contributing and try to ask a question based on their thinking that might help them make a small advance. So it wasn't aiming for like trying to solve the larger problem that they were working on. It was more about based on what I'm listening and hearing you say, I'm going to ask you this question because I think that could support you to make progress. Now, you never know in the moment if you're asking a good one or not, if it's a too big of an advance or not enough of an advance or whatever. But basically, those kinds of things we noted in our data that were coded in a certain way and that we called leveraging questions. And then the PS was the larger challenge. So all of the students had this very large challenge of trying to make two cars travel the same speed and justify it and draw a picture to justify, which both all of that was challenge, especially the drawing the picture and justifying was challenging. So in the terms of the moves that we noticed is that there were sort of two patterns. In some cases, when students didn't seem to have a lot of ideas about the challenge they were working on, we moved to leveraging questions pretty quickly based on just a little bit of information from what the students were saying. That happened with Emily, for example, when she was trying to justify why doubling produced the same speeds. So we kind of moved to leveraging questions, asking her about, well, how are you going to show doubling, asking her what the doubling meant to her, type of a thing, and then followed up on her responses with, FMST, the following up types of questions to try to understand what she had done in response to that leveraging question. And then after that, we might ask another leveraging question and then like kind of continue that on the pathway towards the larger challenge. And then the other pattern was that we might go if students had more ideas, like Lisa, for instance, had ideas about how to draw a picture for doubling without any intervention from us. She just started drawing a picture. It kind of showed that she had something twice as long as this, but of course we wanted to find out what it meant to her. So we asked, questions to try to understand her thinking, follow up type questions about what she was producing. And then a leveraging question like, okay, now you've got this picture where this is double that, you're showing this is twice as long as that. How does that show that you've created same speeds? How does that justify that you've made same speeds? And then, continue the follow up and the leveraging questions depending on what the situation was. So there were kind of two categories of moves that were organized a little differently depending on the student towards working on these larger challenges. Yeah, I think that covers it.
Yeah, great.
Hopefully.
So help us wrap up this 2025 article. What do you see as like
Sure.
a key takeaway for the field, having looked in depth at all these things?
Yeah. So, well, I think for me, decentering provides this kind of really nice foundation for responsive teaching. And we argue in the paper more clearly or more, finely or in more detailed ways about how it can help to provide a foundation or a basis in reasoning for different responsive teaching moves and different frameworks that people have kind of proposed so far. So we don't see it as like itself just a framework. We're not proposing that in the paper, but I think it just provides this like ground for understanding what responsive teaching might look like and why people might engage in certain responsive teaching moves, why teachers might. And that just continues the decentering work of Kevin Moore and Don Tusher and Marilyn Carlson, but in this classroom study with middle school students. So we feel like it kind of amplifies some of the work on decentering that's already gone on. And then we feel like leveraging questions are a kind of advancing question that could be used actually for classroom teachers. I don't think it's really for beginning classroom teachers, but as teachers, refine and classroom teachers refine their practice and develop it, being able to think about a question that just builds on the student's responses a small amount, without necessarily having to get to the larger challenge, and maybe planning for that in some cases could be useful. So I think there's some uses there. For sure, it could be useful for people doing this type of research.
Hmm.
And we talk about that a little bit more in detail on the paper, that, if you're asking too many of these, it might indicate the challenge is too big. If you're asking not enough of them, maybe you want to think about more for teacher researchers who are doing this kind of work.
Hmm.
And then, as I mentioned, the different patterns of decentering actions that might be supportive of students who are facing challenges, we've already covered that.
Yeah.
So those are the sort of the three things I would say.
Yeah, that's great. And as these two articles showed, one analysis leads to another, or they tie in, or like you said, you have a lot of data. Is there some next
Mhm.
steps that your research team is taking, or a next question that you feel like you have to tackle?
Well, I want to continue to try to study this with in other settings. So I have this eighth grade data that it's gotten not enough attention. So I'm going to try to do some work on that with the second order model building, and seeing about the decentering analysis there. So that's kind of older stuff. But I also really want to try to figure out more about how to support classroom teachers to engage in decentering, what's involved, what's useful, what does it look like when it's successful, not assuming that it's going to look similar to how it looks for me as a teacher researcher. And I'm writing a pilot study up about that right now with an eighth grade teacher, where we did a year-long study with that teacher. And I also really wanted to study how teacher decentering influences students' feelings of belonging in math class. I'm trying to get a project funded on that topic. That's the dreams and hopes.
I've been speaking with Amy Hackenberg from Indiana University. And Amy, since this is your first time on the podcast, I do have a couple questions I like to ask everybody if I can.
Sure.
So, first of all, if we go back to where did you do your doctoral studies and who'd you work with, and maybe really briefly, like what was the focus of your dissertation?
So I did my doctoral studies at UGA with Les Steffi. He was my advisor. And I studied sixth grade students' quantitative reasoning with fractions and their early algebraic reasoning, and also how to build a quality of interaction with them that I called mathematical carrying relations. But it was in a small scale setting. It was, two pairs of sixth grade students for a whole year of working with them, a whole academic year.
Hmm. All right, and now if you hadn't gone into math ed as a career, is there something else you could imagine yourself doing in like an alternate universe?
Yes, I've been thinking about that question, and I don't really have a fun answer, but I have an answer that I think is probably realistic, given
Okay.
knowing myself, which is I'd probably either be a human rights lawyer or a medical researcher.
Hmm.
Um, yeah, those are the two things. I think probably I love research, so probably a medical researcher would be more realistic. But I
Hmm.
feel like the former right now, human rights lawyer, is so needed that maybe I could step out of my comfort zone and engage in that way in the world.
Yeah, definitely all ways of making a pretty big impact, make a difference in the world. The
Yeah.
medical research, though, I will say I get intimidated by them just when I'm filling out IRB and I happen to get a glimpse of like the medical IRB stuff and sometimes a question
Yes.
like that right there, I'm like, oh, that's a whole nother beast to do the
Yeah.
medical IRBs. Which
It's
makes
true.
it
It's
makes
true.
sense. It totally makes sense, but
Yeah, and the hierarchical world of medicine probably would never have been that appealing to me, but I think I would have liked being a researcher. So,
well, thank you so much for taking the time, and I'm really glad that we
mhm.
could actually kind of handle both of these articles. I feel like something would have been missing if we only looked at one of them. So thanks for taking the student perspective and the teacher perspective into analysis.
Yeah, yeah, for sure, Sam. And I appreciate you and I appreciate your podcast, and it was a pleasure to be here.